In this video, we are going to continue our factoring and talk about what happens when a is not 1 and you cannot factor a GCF. There's a couple ways that you can go about these. One is called guess and check. Guess and check becomes useful when you notice patterns. Some people like this because they have some number sense and can think about what numbers are going to be useful. Others struggle with this because you're literally guessing and checking and hoping for the best. So when you have a problem like this, we're going to factor 3x squared plus 8x plus 4. We have to also kind of think about foiling to check our answers. So we try to guess all possible factors of a and c that result in the middle term of b. So for this one right here, we have 3x squared plus 8x plus 4. We know that when we FOIL, the first two numbers will have an x squared. That means you know that one of them has to be 3x and the other one has to be x, because that is the only way you can multiply to get 3x squared. Then you think about your c term. Okay, with our c term, we have the number 4, so we could have 4 and 1 or 2 and 2 as our factors. And it does matter where you put them, because when you FOIL, like if this was a 4 and this was a 1, let's say we did this, this is going to be 4 times x, and this will be 3x times 1. But if I would have flipped those instead and put the 4 here and the 1 there, now this 3x times 4 becomes 12x, and the 1 times x becomes 1x as well. So it does matter where you put those c terms. So I just tried both. I just tried the factors of 4, 1 and 4, and those didn't work. So let's try 2 and 2. And again, you can check this and say, okay, 3x times x is 3x squared. 3x times 2 is 6x. 2 times x is 2x. And 2 times 2 is 4. When you combine your like terms, 3x squared, 6x plus 2x is 8x plus 4, which is what our original problem was. So the correct factored form, and I'm just going to write it again down here a little bit neater, is 3x plus 2 times x plus 2. That is our factored form. Like I said, some people like it because they have the number sense to go through and find out your factors and guess and check. Others don't, because you're constantly guessing and checking, and it could take a while that way. Another method that we can use is called X and grouping, or sometimes called factor by grouping. And this one is more of a process that will get you the correct answer, but it does take a little bit more work. So there's a trade-off. Like I said, this will work all the time, but it is a little bit slower in some cases. So what we want to do is we want to find two numbers that multiply to a times c, but those two numbers also have to add up to b. So I'm going to take 4 and 15, and we get 60. So we need two numbers that multiply to 60, but also add to 16. And if you want, you can use your calculator and start dividing 60 by numbers to see which two numbers will give me a sum of 16. We can do 6 and 10. That gives me 60. 6 plus 10 equals 16. So my two magic numbers are 6 and 10. Let's write that down here. What we're going to do is we're going to break up that 16x. And what I mean by that is, instead of writing 16x, we're going to write 10x plus 6x plus 15. Now, one of the questions I get is, does it matter which order we do that in? No, it doesn't. I could have put 6x plus 10x. And if you were to combine these, 10x plus 6x equals 16x. So what we're doing is we're doing the opposite of my check up here. Right here we had 6x plus 2x and we combined it to 8x. We're going in the other direction. We're going from 8x to the previous step. Except in this problem, from 16x, we're going to 10x and 6x. Then what we're going to do is we're going to look at the first two terms and say, what is the GCF of 4x squared plus 10x? You can divide or factor a 2 out of that and an x. They both have an x in common. So we have 2x, and what is left inside is 2x plus 5. And again, if you wanted to, you could multiply this back. 2x times 2x is 4x squared, and 2x times 5 is 10x. That's just something I will do sometimes in my head, quickly, just to make sure I've done this correctly. Then here I have 6x plus 15. The GCF of this problem, or sorry, this part is 3. You can factor out a 3. And what we are left with, if I divide 6x by 3, I get 2x. 15 divided by 3 is 5. So notice how these two things match. They should be the same. If they are not the same, then that means you messed something up with factoring. Now, the next step would be to, the thing that I highlighted, write that out front, and then the things that are left, 2x plus 3, is going to go in the other parentheses. So this is my factored form, 2x plus 5 times 2x plus 3. So factored form of that problem was 2x plus 5, 2x plus 3. Okay. Some classes, like our pre-calc class, does prefer guess and check, but this method will work too. This problem here, 3x squared minus 10x plus 8. I'll do this one by guess and check. So when I guess and check, I'm going to have 3 parentheses. One of the reasons why I'm going to guess and check this one is because my A term is 3x, which means I have to have this as my first two terms, 3x and x, because those are the only two things you can multiply together to get 3x squared. Now, for the other parts, I have 8. So my factors of 8 are 1 and 8 and 4 and 2. So I don't have a lot of factors of factors of 8. So what I'll do is I'll try to think, all right, I need to have negative 10x when I add them up. So I'm going to start, I'll do this, and I'll just kind of guess and see, does this work? 3x times 2 is going to be 6x. So let's write this down. So if we were to FOIL this, 3x squared plus 6x minus 4x minus 8. Okay, so that doesn't work. Got to erase that. I need to change this to a minus sign. And the reason I'm changing it to a minus sign because I got to get two numbers that multiply to negative 8. All right, now if I try this again, all right, 3x times x is 3x squared. 3x times negative 2 is negative 2x. Sorry, negative 6x. Negative 4 times x is negative 4x. And negative 4 times negative 2 is positive 8. And we can combine our like terms and get 3x squared minus 10x plus 8. which is what we originally had at the beginning. So my factored form is this. I am personally not as big of a fan of guess and check because I just don't like the idea of saying, oh, just guess and hope for the best. I want to be able to explain, this is what you can do to always get the answer. In letter B, I would not do this one with factoring by guess and check. I would use grouping instead because 6 has a lot of factors. It has 4 factors. Negative 15 has 4 factors. So there's a lot more potentially wrong answers to guess and check. What we need to do for factoring by grouping is multiply 6 and negative 15. So in my calculator, if I type that out, 6 times negative 15 is negative 90. Let's write that over here. So I need two numbers that multiply to negative 90, but when I add them, I get this positive 1 that we had in front of x. Two numbers that come to mind are 10 and negative 9. 10 times negative 9 gives you negative 90. 10 plus negative 9 gives you positive 1. So then I'm going to split this up. You have 6x squared. When I do the next part, 10x minus 9x, I want to point something out, and then I will discuss a way to remedy the situation. 6x squared plus 10x, what I can factor out of this part right here, what I can factor out from here is 3x. And I'm left with 2x. I'm sorry, I can't factor out 3x. I can factor out 2x. Factor out 2x, and I'm left with 3x plus 5. Now, in my second set of parentheses right here, you say, oh, I can factor out a 3. Just like before, when we wanted to factor out negatives if we could, if this is negative right here, we want to factor out a negative value. So instead of factoring out a 3 between 9x and between negative 9x and negative 15, I'm going to factor out a negative 3. So then that means I am left with positive 3x plus 5 because I factored out a negative number. All right, so then the thing that I see twice, that's repeated. So 3x plus 5 times what's left over, 2x minus 3. All right, letter C. I'm going to do this one by grouping just because that's what I like to do the most. That's what I prefer, especially with like negative 12 there. You have so many factors of negative 12, 1 and 12, 3 and 4, 2 and 6. That's a lot to deal with. So 3 times negative 12 is negative 36. Two numbers that multiply to negative 36 but add to positive 5. That's going to be positive 9 and negative 4. Positive 9 plus negative 4 gives you positive 5. Positive 9 times negative 4 gives you negative 36. So we'll break this up. 3x squared. Now, like in the last problem, we have a negative factor and a positive factor, and we said we got to factor out a negative from this part right up here. What you could do instead is make sure to put the negative first. That way, when you factor out from here, these two, you don't need to worry about factoring out a negative sign. Whoops, I forgot the plus. And then when I factor out from these two, that 9 is already positive. That number in front is already positive, so I do not need to worry about factoring out a negative value. So I do it that way, just if I have the option. So if one of my magic numbers here is negative and one's positive, I always put the negative one first, just to make factoring easier. So between 3x squared and negative 4x, the GCF of that is just x. You can't factor out anything else. So then you're left with 3x minus 4. Then 9x minus 12, I can factor out a 3. And I'm left with 3x minus 4 left over. If I divide 9x and negative 12 by 3, I'm left with 3x minus 4. So, whoops. 3x minus 4. And then what's left over is x plus 3. And then we're done. So what I want you to do is I want you to pause the video and try these problems. Once you are done, unpause it to check your answers. I'll have some of the work shown for these so that you can see, maybe where you went wrong, if you did go wrong. But I want you to try these on your own. All right, so here are the answers, and you can see for the first one, the team one, I showed the work of me breaking it up to factor by grouping, and then the other ones I just showed you the answers so that you could see what you got. So then on the next page here, we talked about these special patterns, and these special patterns also work when a is not equal to 1. So we have 81x squared minus 25. This is a difference of squares because 81 is a perfect square. So what you can do with this one is use your difference of squares formula and call this one, 9x, let me write that down here instead, 9x minus 5 times 9x plus 5. Because the square root of 25 is 5, and the square root of 81x squared is 9x. Square root of 81 is 9. The square root of x squared is x. So again, you could say that your b value is 0 and do the whole process again. It would take time, but if you recognize that this is a difference of squares, that will get you to your answer faster. Now with examples number 8 and 9, we can use these special perfect square trinomials. We look at this problem here, 49z squared plus 112z plus 64. We have 49z squared, which is a perfect square. That's going to be 7z. 7z, 7z. And 64, the square root of 64 is 8. So it's going to be plus 8, which could also be written as 7z plus 8 squared, since we have the same thing. Now, like I said, if you don't recognize this, you could do 49 times 64, and then it's going to be a very large number, and say what two numbers multiply to that number, but then add up to 112. And then go through all that factor by grouping. Example 9, we have a minus sign, so it's going to be the same process, but it's going to be a minus sign in the center. 9r squared, the square root of 9r squared is 3r, so 3r goes first, and then the square root of 121 is 11. And again, we could write that as 3r minus 11 squared. And you really need to look to see, is this a perfect square and is that a perfect square? If they are both perfect squares, then you could use these shortcuts. If they are both not perfect squares, then you have to do what we did up here, guess and check, or factor by grouping. All right, down here, we're going to factor these using those things up here, those shortcuts. So we have m squared minus 121. Those are both perfect squares. M squared is m to the second power. And 121 is 11 squared, so we have a difference of squares. So we're going to have m minus 11 times m plus 11, their difference of squares. When I look at letter B, I see that we have 9n squared, which is a perfect square, and 25, which is a perfect square, and it's a plus sign in the middle. So this would be a perfect square trinomial, and we're going to do 3n plus 5 times 3n plus 5. And again, that will simplify to 3n plus 5 squared, because this is a perfect square and that is a perfect square. Letter C, this is a perfect square and that's a perfect square, so we can do the perfect square trinomials. So 4y, and because we have a minus, it's going to be 4y minus 5 times 4y minus 5, or 4y minus 5 squared. So letter D is also a difference of two squares, because 4x squared is 2x squared, and 81 is 9 squared. So we have 2x minus 9 is 2x plus 9. And again, because we're multiplying, you could write this as 2x plus 9 and 2x minus 9. It means the same thing. So what I want you to do is, I want you to do these three problems down here, and you could use any method you want. We have a lot of tools. Remember, the first thing you want to look for is a GCF. That is the number one easiest thing to look for. If you can factor a GCF, do that, and then it might be a little bit easier to factor. So go ahead, pause the video, try these, and check your answers when you're done. Okay, these are the answers, and I want to point out letter D, that once you factor out a negative 25, you have m squared plus 4. That is not the same as m squared minus 4. There is no such thing as a sum of squares when it comes to factoring, just the difference of squares. So these are the correct answers. If you need to go back and recap on anything, feel free to do so. But otherwise, thank you for watching the video. Make sure to like and subscribe.